Today we're going to look at a set of identities that involve sums and differences of angles. And we'll start out looking at a unit circle. And I want to draw a couple of just arbitrary line segments here that I'll use as terminal sides of angles. For the first angle I'll call alpha. It will be the angle that's formed when we rotate the blue segment from the x-axis in a counterclockwise direction. And of course, that corresponds to the point cosine alpha, sine alpha. Likewise, when we rotate the red segment counterclockwise from the x-axis, we get an angle that I'll call theta. And it, of course, corresponds to the angle cosine theta, sine theta. Now, one more angle I want to label, and that is the angle formed by the blue and the red segment. And I want to write this angle, I want to label it in terms of alpha and theta. In that case, that would be alpha minus theta. So here's what we have so far. And what I want to do is take special note of the distance from cosine alpha sine alpha to cosine theta sine theta. And I'll go ahead and connect those 2 points with a segment. And to aid with the visualization, I went ahead and filled in the triangle that's now formed by the 2 segments and this line connecting the points. Because what I want to do is I want to rotate the red segment, this whole triangle actually, theta units, or theta degrees, theta radians, whatever unit we're in, I want to rotate this triangle that many units in the clockwise direction. And let's see what happens. Now, the point cosine alpha, sine alpha has been translated now, and now we have this new point that's cosine alpha minus theta, sine alpha minus theta. Now the reason for that is because really this line right here is the terminal side of the angle alpha minus theta. Notice all we did was we rotated this triangle around. The angle alpha minus theta was preserved, and now it corresponds to a point formed on the unit circle when we rotate this terminal side clockwise or counterclockwise alpha minus theta units from the x-axis. So it's the translated terminal, it's this terminal side over here for cosine alpha, or for the angle alpha, has been translated, and now it's a terminal side for the angle alpha minus theta. Okay, now let's go ahead and label what we have here. We have cosine alpha, sine alpha. We have cosine alpha minus theta, sine alpha minus theta, and cosine theta, sine theta. So I've gotten rid of the triangle now because we're finished with it. It's no longer an aid to us to observe the rotation. Now, here's what we want to take note of. We want to look at the distance from cosine alpha to sine alpha. The distance from cosine alpha, sine alpha to cosine theta, sine theta. And the distance from cosine alpha minus theta, sine alpha minus theta to the point 1, 0. Now, those distances are the same. Because remember, the way we got this line segment from cosine alpha minus theta, sine alpha minus theta to 1, 0, the way we got that is simply by rotating the segment from cosine alpha, sine alpha to cosine theta, sine theta. So those segments have they're the same length. Now mathematically, using the distance formula, notice in yellow I've indicated the length of that segment algebraically by the difference of the x's squared plus the difference of the y squared, the square root of that, and also the segment in green from cosine alpha minus theta, sine alpha minus theta to 1, 0. That distance is the square root of also the difference of the x's squared plus the difference of the y squared. Square root of that. Now that we've established this, that these two distances are equal, let's see what happens. Let's see what we can come up with when we set these two distances equal. In other words, when we set this expression in the yellow box equal to the expression in the green box. Let's put set these equal, do some algebraic manipulation, and see what we come up with. Now, to save a step, I'm going to set the square of these distances equal. In other words, I'm going to leave the radicals off. If we leave the radicals on, the first step would be to square both sides, and there's no point. We'll just set the squares equal, the square distances equal, and simplify. Okay, so here's what we have. We have the left-hand side and the right-hand side. Now, let's begin. We're going to first of all multiply out this first squared term. We'll just expand the first squared term, and of course you see clearly what we get there. Now we'll multiply out the second squared term, and you can see what that yields. So, we've multiplied out the left-hand side. Now we're ready to move over to the right-hand side, and notice we've got another squared term that we need to multiply out. And then finally, the last term, the sine alpha minus theta minus 0 squared, which of course is just sine squared alpha minus theta. Now, before we go to the next step, we're about ready to do a little bit of simplifying here, but I want you to recall a Pythagorean identity that says that sine squared t plus cosine squared t equals 1. Anytime you see sine squared t and cosine squared t together, plus that sum, sine squared t plus cosine squared t, anytime you see that, you can replace that expression with a 1. Now, we see it in a few places up here. We see it, first of all, cosine squared alpha plus sine squared alpha. So, when I'm rewriting this left-hand side, I just wrote that as a 1. Now, that's not the only place we see this. Notice there's another one because I have cosine squared theta plus sine squared theta. Now, once we do that, we just write down what we have left, and all we have left is this negative 2 cosine alpha cosine theta minus 2 sine alpha sine theta. And that takes care of the entire left-hand side. Now we're ready to move over to the right-hand side. And notice that I've got sine squared alpha minus theta cosine alpha minus theta. So that's obviously going to be written as a 1. And I put that 1 here. And we already had a 1, and then negative 2 cosine alpha minus theta. So we've got the entire left-hand side, or the entire left-hand side and the entire right-hand side finished. Now, notice this, that on the left-hand side of this expression, of this equation, we've got a 1 plus 1. There's 2 there, and over here we've got a 1 plus 1. That's 2. So those are going to cancel out, and we can now rewrite without using, or without the 1s. Now all we have is the negative 2 cosine alpha cosine theta minus 2 sine alpha sine theta equals negative 2 cosine alpha minus theta. Notice that a negative 2 is common in each of these terms, so I can divide that out. And voila, I get this expression. This is the difference formula for cosine. And this is the first one of our identities that we want to take note of. The cosine of a difference of angles, alpha minus theta, is equal to the cosine of alpha, cosine theta, plus sine alpha, sine theta. Now that's the first one. We also want to derive the cosine of a sum of angles. Cosine of alpha plus theta, then the sine of alpha minus theta, and the sine of alpha plus theta. So let's proceed to the cosine of alpha plus theta. Now, first of all, I've simply just rewritten the formula that we just derived. Now, I want to use the same formula, but instead of alpha minus theta, let me just replace theta with negative theta. Okay? So that hasn't violated any rules. I've still got the difference of angles here. So I've got the cosine of alpha minus theta. Well, that, of course, would be cosine alpha, cosine negative theta, plus sine alpha, sine negative theta. Now, why would I do that? Well, to understand, we need to recall a couple of things here. One, that cosine is an even function. Cosine is an even function. That means that cosine of negative theta equals cosine theta. And also, we need to remember that sine is an odd function. The sine of negative theta equals negative sine of theta. So whenever we see cosine negative theta, we can just replace it with cosine theta. Wherever we see sine of negative theta, we replace that with negative sine theta. So what does that give us? Well, notice, I'm going to be able to take this cosine negative theta and just rewrite it as cosine theta. But over here, sine negative theta, I'm going to rewrite that as sine theta, but I have to remember the sign of this term is going to change. So here's what I'm going to get. I'm going to get cosine of alpha plus theta equals cosine alpha, cosine theta, minus sine alpha, sine theta. And that is our second formula that deals with sums and differences of angles. This is, of course, cosine of the sum of angles, alpha plus theta. Okay, now let's look at the difference formula for sine. And let's just take note of something that is obvious. If we have two angles, pi over 2 minus beta, that's one angle, and beta. Notice that those two angles add up to pi over 2 because the betas obviously cancel out. Now, because that happens and because sine and cosine are cofunctions, that means that the sine of pi over 2 minus beta is equal to the cosine of beta. And also cosine of pi over 2 minus beta equals the sine of beta. This is a property of cofunctions. Remember, if you have two angles, A and B, and if those two angles add up to pi over 2, then sine of A equals cosine of B. So we want to make use of that in deriving the difference formula for sine. So here we go. Notice that we start off by just writing, okay, let's see what the difference formula would be. Sine of alpha minus theta. Well, let's look at this. This is going to be that's going to obviously be equal to the cosine of pi over 2 minus alpha minus theta. When you look at this angle, you're looking at this as one angle, alpha minus theta. So this would be obviously equal to cosine pi over 2 minus alpha minus theta. And now I just want to do a little rearranging, pull the alpha in with the pi over 2, and we get cosine pi over 2 minus alpha minus a negative theta. Now let's see what we can do with that. Well, turns out we can use the formula that we recently derived, the difference formula. Notice here's the cosine of angle 1 minus angle 2. See? First angle, second angle. So that means, using our formula, we've got the cosine of the first angle times the cosine of the second, plus the sine of the first angle times the sine of the second. Now remember, I can write cosine of pi over 2 minus alpha as sine alpha. And I can write cosine negative theta as cosine theta. I can write sine of pi over 2 minus alpha as cosine of alpha. And sine of negative theta, I can write that as negative sine theta. So let's see what we have here. Notice that I've rewritten, as stated, I've rewritten cosine pi over 2 minus alpha as cosine alpha. I've rewritten cosine negative alpha, theta as cosine theta. And sine pi over 2 minus alpha as cosine alpha. And finally, the sine negative theta, I've rewritten as sine theta, but I've changed the sign of the term in general. So what we have now is we have our first formula involving sine, the difference formula. Sine of alpha minus theta equals sine alpha cosine theta minus cosine alpha sine theta. Okay, so we've got sine alpha minus theta. We just derived that on the previous slide. Now let's play the same game that we played when we were deriving the sum formula for cosine. Let's substitute in place of the theta, we'll replace it with negative theta. And notice then what we have. We have sine alpha cosine negative theta. Remember, because cosine's even, I can rewrite this just as cosine theta here in a minute. Minus cosine alpha sine negative theta. Now because sine is odd, remember what's going to happen here. I'm going to rewrite this as sine theta, and it's going to change the sign of this term. So let's see what we have. Okay. Okay. Now, so notice here, this step here, I just rewrote alpha minus a negative theta as alpha plus theta, because these two negatives. Now, what we get as the end result is cosine alpha plus theta equals cosine alpha cosine theta plus cosine alpha sine theta. And this is our last formula involving the sums of differences that we're going to look at. Now, let's look at a summary. The identities. First of all, we have the cosine of a difference of angles, the cosine of sum of angles, sine of a difference, and the sine of the sum of angles.